Welcome, ladies and gentlemen. We're on to our next part of energy. Yesterday we learned about that energy that's stored. What's it called? Yes, potential energy, and we learned about 4 different types. Well, today we move on to kinetic energy, and we're going to look again specifically, this time at 5 different types of kinetic energy. Kinetic energy is the energy of motion. Let's start. First category, electrical kinetic energy. The energy of moving electric charges. Examples would be lightning, charged particles moving through a circuit. Now you use electrical kinetic energy all the time. Alright, for instance, here we have a setup like with a flashlight, okay? And the electrons flow through what's called a circuit. And as they flow through the circuit, they are transformed into some other kind of energy that we want to use. So, let me explain. If I take a battery, yesterday we learned this is potential energy. It's chemical potential, a chemical reaction waiting to happen. And when the chemical reaction happens, electrons start flowing from one end of the battery to the other. How do we start it? Well, we just connect a wire. We take a wire and we connect it from one end to the other. Now, we don't want to do that and have nothing that it's hooked up to, because it does what's called short-circuiting the battery. It runs its electricity out very quickly. The chemical reaction happens real fast and the battery's no good. Sometimes you'll even feel the wire get hot because of those electrons flowing through it. What we want to do is we want to hook it up to something where it can do something useful for us. Now, you may not be able to see the electrons flowing through that wire because you can't see them. But you can sure see what they do. Alright? They transform into radiant energy, that's light energy, when they go through the bulb. Okay, so even if you can't see electricity, even if you can't see electrons, we know that they're flowing through the circuit because they get transformed into a different form of energy that we can see. Here's another one. Okay, I'm going to put electrical energy through this wire and watch what happens when those electrons flow through the motor. This is kind of cool. I like this one. Oh yeah. Oh yeah. That, my friends, is what electrons can do when they go flowing through a motor. We're going to learn how a motor works later. But electrical kinetic energy. Now remember, as long as it's still in the battery, it's potential, because it's a chemical reaction waiting to happen. But once we hook up that wire, the chemical reaction happens, the electrons move. And when they're moving, they're kinetic. Here's a fun one, the second one. Radiant energy, okay? That's the energy that travels as electromagnetic waves. Okay, what the heck is an electromagnetic wave? I mean, you know what a wave is, right? Okay, let's everybody work with me here. We're going to make a wave. Okay, so with your hand, make kind of the shape of a wave. Yeah, there you go. You probably did this when you went to the dance, right? I better stop. Okay, but now imagine that you actually have 2 waves combined, okay? So one is going this way. Let's say this is the electric part. It's going this way. And then you've got another one, the magnetic part of the wave, that's going the other way. Okay, I better do this towards you so you can see. So one's going up and down, and the other wave's going side to side. And they're both moving at the same time. They're both part of the same wave. It's an electromagnetic wave. Okay, so try this now. This is pretty crazy. So one goes up and down, and the other goes side to side. Ooh, wow, check that out. And they're all parts of the same wave. Whoa, this is kind of fun. Sorry, I got a little carried away there. Electromagnetic waves. So what are these waves good for? Well, you got to understand there's all different wavelengths. Okay, so like with your hand, you know, imagine you make a big long wave, or you can make a little short choppy wave. Well, the cool thing is electromagnetic waves, you can only see a particular wavelength of them. What wavelength is that? Well, this little chart explains that to us. Right here, about in the middle, we have what's called visible light. Visible light is an electromagnetic wave, a form of radiant energy. If that wave is just the right length, we can see it. All the other ones we can't. Let me show you the other ones. They range from really cool to really dangerous. Over here we have radio waves. You know, you see somebody walking around, they got their headphones on and they're bopping away. Well, the whole reason that they can hear a radio station is because there's these invisible waves in the air carrying the music. That's radio waves. They're the longest ones. Okay, as they start getting a little shorter, we get microwaves. They're those waves that go through the microwave, and when they hit your food, they make it get hot. Then we have something called infrared. Okay, that's like a heat lamp. All right, and when you get under a heat lamp, you can feel the heat coming in those waves. Then of course we have the visible light. Then we have what's called ultraviolet light. That's light you can't see, but it can still hurt you. Like get a sunburn, you know, do damage to your skin. Now we're getting to the really short electromagnetic waves. We have the X-ray. Now the X-ray starts to get a little dangerous. You don't want to get X-rays too much. Once in a while won't hurt you, but too much, and you can get some harm to your body, because these rays, as we get down on this end, these electromagnetic waves start to get a little dangerous. Gamma ray. Hey, remember that symbol? We learned it yesterday. That's right. Gamma rays are electromagnetic waves that have so much intensity it's kind of like poison to you. Invisible waves that can poison your body. Weird. All right. So that's number 2, radiant energy. Number 3, sound energy. Energy given off by vibrating objects. That's energy we can hear. Yeah, did you know that even though you can't see them, sound waves are actually particles moving through the air? Yeah, they're kinetic. They're moving. This picture I kind of like because it shows what you could see if you could see the sound waves. If you could see them, they would be like these little squishy parts and little kind of, no, I can't describe it. Anyway, they're out there. You know they're there because when they get to your ear, they make your eardrum go waka 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 waka, vibrate. Again, if we could see them, sound wave would be made up of these little squished parts called compressions and these little unsquished parts called rarefactions. If you get really close to a loudspeaker, you can actually feel the sound waves. Sound waves, another form of kinetic energy. Now this is the one that everybody thinks of when we talk about kinetic. This is called mechanical energy, and it's actually objects in motion, okay? The energy of motion. Here we have windmills in motion. Here we have a water wheel in motion and water in motion. Here we have a little guy pumping iron. He's in motion, a body in motion. And here we have, yeah, the grave digger. And as some of my students know, that thing can move. It can move, it can even flip over. Mechanical energy, the energy of motion. So you got to remember this specific term now, because we don't just say kinetic. We say mechanical kinetic when we're talking about an object that's actually in motion. Ah, another cool one, thermal energy. How is heat moving? Well, remember, this is energy of the moving particles that make up matter. Okay, that's what thermal energy is. Thermal energy is like how much of those little particles inside you moving, or how much of the little particles inside some object moving. The more they're moving, the faster they move, the more thermal energy that object has. So here we can see as these arrows get longer, it means the particles are moving faster. There's more thermal energy. With the smaller arrows, it means the particles aren't moving as much, less thermal energy. They have this cool kind of camera that can take what's called, it's called thermal imaging. It can take a picture that shows how hot the different parts of something are. I think the darker the red, the hotter it is, and the more yellowish, the less hot. Pretty cool. They can use this to like help find people who are hiding in the woods. Okay, thermal imaging. All right, so that's 4 of them, but I told you there were 5. Did we miss one? We better go back and check. Nope, we got them all. Let's review them again real quick. Electrical energy, the energy of electrons moving through a circuit. Radiant energy, that's the energy of those special electromagnetic waves. Don't get me started again. Sound energy, the energy of moving air particles carrying sound. Mechanical energy, the energy of moving objects. And thermal energy, the energy of moving particles. Now, what we've learned is 5 different types of kinetic energy, but remember I told you the other day, energy is always changing forms. First it's one thing, then it changes into another. I mean, we had electrical energy, but then it changed into the moving energy of the little propeller. You know, that's mechanical, okay? They're always changing. So, we need to learn something called the law of conservation of energy. It says, I'd like you to repeat this with me now. Energy is neither created nor destroyed. It simply changes from one form into another. Ready for words to start dropping out? The law of energy states that energy is neither nor destroyed. It's simply from one into another. You got that? Wow. This is getting a little tough. The law of energy is neither nor. It's simply from one into another. Let's do that one last time. You ready? The law of energy is neither nor. It's simply from one into another. And this little diagram down here shows some energy transformations. For instance, how the energy of the light from the sun gets stored in plants during photosynthesis. The energy of electricity that flows out of the socket gets turned into heat to heat your food. The energy, the chemical energy stored in the food that you eat is changed into the mechanical energy of your body moving. The chemical energy of gasoline is changed into the mechanical energy of your car. All these different kinds of transformations, and we're going to start looking next at how energy transforms from one thing into another.